Cast iron cookware is renowned for its superior ability to retain heat and diffuse it evenly. However, bare cast iron requires regular oiling to ward off rust. Not so with enameled cast iron. A glass enamel coating encases the iron, making the cookware entirely maintenance-free forever. Since 1925, this French company has been producing enameled cast iron cookware. Its high-end products are renowned for their thin walls, which makes it the most lightweight cast iron cookware available. The secret? The mineral levels in the iron recipe. At the foundry, they begin with pig iron, which has a high carbon content. Then they melt in a calculated amount of steel to further boost the carbon level. The melting oven heats the metals to 1520 degrees Celsius, liquefying them in just 45 minutes. Workers add a powdered chemical to agglomerate the natural impurities in the iron, then scoop those bonded impurities out. Meanwhile, workers mount a two-part mold template onto a machine which produces the sand molds with which they'll cast the cookware. The machine injects the sand mix into the templates. The mix contains clay, water, and proprietary ingredients which make the sand compact well. Compaction is critical because just one single grain of sand displacing from the mold would produce a flaw on the cookware. It's essential that the pouring temperature be precise and consistent, so they transfer the iron from the melting oven to a temperature maintenance oven. From there, they pour the molten metal through a mere 3 mm gap between the mold halves. The process is entirely automated because the pouring angle and speed are critical. The molten iron cools and solidifies in 20 minutes. Then the molds drop onto a vibrating mesh conveyor. The shaking releases the cast cookware from the mold, along with the metal that's solidified in the flow channels leading to the mold cavity. The cookware moves into a closed chamber where a high-pressure gun blasts the surface with steel balls to remove all remaining grains of sand. At this stage, the cookware has rough excess metal where the two parts of the mold met. So now workers smooth away these burrs using a grinding wheel on the outside and a grinding pen in the tight spots. The cookware is now ready to be prepped for enameling. A machine now blasts the entire piece with steel grits, making the surface texture uniform so the enamel will adhere evenly. The first coat of enamel is strictly to protect the cast iron and prevent it from rusting. Enamel is a form of glass. However, this enamel is engineered to be flexible because metal cookware naturally expands as it heats and contracts as it cools. After a trip through a dryer, the enamel goes into an oven at 850 degrees Celsius for about 45 minutes. During this firing, the hair-thin enamel coating becomes translucent. The second coat of enamel completely seals the porous surface. It's made of some 20 components, including enamel chips, pieces of clear glass, and pigment powders for color. An automated spray system coats the inside first. Workers wipe the edge to prevent the piece from sticking to the conveyor, then the handle because they'll paint that a different color. They spray the handle manually, then the automated system coats the rest. The iron recipe contains a high level of the mineral silicate, which helps the enamel adhere well. Once again, the cookware goes through the dryer, then into the oven at 850 degrees Celsius for about 45 minutes to vitrify the enamel. Once the cookware cools, it undergoes a final visual inspection, the last of 30 quality control checks throughout the production process. Enameled cast iron cookware lasts generations because it doesn't warp over time and remains food safe for life. Pyrex is an idea cooked up by the wife of a glass industry scientist in 1913. She believed the tough glass used in lantern globes would be great for baking cakes in, so she baked one in some glass her husband brought home. The cake was a hit, shattering the notion that glass was too fragile for the oven. Today, you'll find glass cookware of various shapes in most homes, a true recipe for success. To whip up some dishes, a batch feeder pushes ingredients into a big furnace as they spill out of a bin overhead. Silica sand is the biggest part of the mix. It's a crystalline substance and it makes glass transparent. The batch also includes soda ash and recycled glass. Some of the other ingredients are a trade secret. The furnace heats the mix to the melting point, over 1500 degrees Celsius. It turns into molten glass that looks like lava. The glass, in this lava-like form, will spend up to 24 hours in the furnace. On its way out, mechanical shears cut it into gobs. The gobs slide down a water-cooled chute and drop into a baking dish-shaped mold. There are 16 molds on a rotating table. As it turns, the table delivers the gob-filled molds to a plunger, which presses them into the baking dish shape. Continuing to rotate, the table positions the molds under blowers. They cool the freshly molded glass so it holds its shape. A mechanical arm suctions up the glass dish and sets it down on another revolving table. Flames lick the glassware from burners above and below. The dish is exposed to a temperature of over 1000 degrees Celsius. This softens its sharp edges so that the rim is smooth. Next, hoses blast high-pressure air, cooling the dishes to solidify them, so that a mechanical arm can pick them up without ruining them. It transports the glass dishes to a conveyor belt. Further down, another arm feeds the dishes to a kiln, where heating and cooling cycles temper the glass. This is what gives Pyrex its strength. Now it's time to put a lid on things. A different plunger presses glass gobs into a lid shape. Every lid needs a knob, so a valve inside the mold forms it and then thrusts the lid up to be picked up by a mechanical arm. The arm flips its lid and sets it down on a conveyor belt. The lids are on the move, traveling through a tempering kiln. On their way out, a fan cools them off so they can be handled by human hands this time. Workers inspect each glass lid before packing them. On another line, there's a product that's made to measure. Little platforms lift the measuring cups to suctioning arms that protrude from a revolving silkscreen machine. A little squeegee forces enamel through a screen, printing measurements onto the cup. Over in the lab, a worker roughs up a sample dish. By rubbing it with sandpaper, he mimics years of wear and tear, but it's about to be subjected to even more abuse. He places a sharp tool in the center of the dish and takes aim with a hammer. Will it break without shattering into numerous little shards? It's a clean break, which means this dish has met the quality standards.